There's a lot of things you can believe in the world today, but when you start believing in a young earth, well, that's kind of the edge of the edge kind of a thing. You can even believe in God. A lot of people will accept that kind of thing. But a young earth, you know, that's just sort of over the pale. That's those crazy people, you know, way on the right or something like that, okay? So what I'm going to try and do today, my view usually is I try and make a case for it, what things point to it. And so I've tried to gather a lot of different things that way. Now I had a really nice PowerPoint put together, and when they asked me to come and speak, I started looking for it, and well, let's just say over the course of time I couldn't find it anymore. I thought I backed it up here, I thought I backed it up here, and it disappeared, all right? So tonight's presentation, I sort of brought a lot of these things together. I'm going to use a couple other different mediums. Eventually we'll probably get to the DVD. So I want to semi-apologize in front that it was a really nice presentation, and someday it will be again as soon as I find all the pieces again. And I've been taught the lesson of backing up in multiple places now, so I'm sorry about that. So tonight I just want to sort of make the case for it. Okay, it would be nice if, for instance, there was some place in Iceland we can go back, pull back the sod, and it says made by God 4004 BC or something like that. Of course, nobody would believe that either. They'd say it was a forgery or something like that. When you think about it, 6,000 years old is actually a long time. All right. Anybody here? No, yeah, none of us, you know, there's some of us who are, you know, I'm gray now here too. And, but it's 6,000 years, no. Usual lifespan of a person is about 120 according to the Guinness Book of World Records, according to what it sort of says in the Old Testament, how long a lifespan will be post-flood. So tonight I'm just trying to make the case for it. We can discuss each point. Obviously there's caveats and things, particularly when we get into rock dating. We're going to look at all kinds of ways to try and date things, all right? Some of them, or all of them, have assumptions built into them. You have to assume, you know, the starting condition. Okay, what was the clock like when everything got going? All right, a lot of times you have to assume a constant rate.
All uranium, no lead.
All right, constant rate of, for instance, decay, uranium to lead, these sorts of things. But all the clock measurements have this in them. All right. And you have to assume you know end products and these sorts of things. So there's a lot of different things. For instance, if you tried to date a person just by looking at them, what are the things you would want to know? You know, well, if you could ask them their birthday, there you go, you got that. All right. There's certain characteristics, though, we know as you grow older what happens. All right. Gravity gets stronger, and lots of different things. Okay. And so we can tell by your bone density, we can tell by all sorts of stuff now in scientific measures. This is what the forensic scientists use when they find a body. You know, they can tell how old it is just by looking at various features on it, because these are all characteristic and generally constant. However, if you get somebody who has a pituitary giant, for instance, some people whose pituitary glands are overactive. The largest man in the Guinness Book of World Records, Robert Wadlow, was 8'11" when he died, and he was 22 years old. He just started growing like crazy. Okay, this happens sometimes when people have injuries and all that, and so there's various other things that come into play when you do that. All right, so I'm gonna enough. Okay, try not to move around because I know it makes you guys move that around. Okay, I'm going to try and look at various other aspects of things. And I used to get these kinds of questions in the museum all the time. That was the thing that really stuck in people's craw, so to speak, was the age of the Earth. You just can't go there. Turns out there's lots of different lines of evidence, I think. Let's see if I can get it going here. Yeah, you're not going to do that for me today, are you? No, doesn't like that. All right, try that. No. Okay. Biblical reasons for a young earth. We're going to look at these a little bit first. All right, you know in the Bible, those chapters generally everybody skips over, starting around 5 or so. Someone beget so-and-so when he was so many years old. All right, and when you add up those dates, depending on the version you use, and there's difference between, I know there's differences between the Septuagint and some of these others, and I won't get into all the nitty-gritty there, but you generally have pretty long lifespans. For instance, Adam, according to Scripture, lived 930 years. All right, Seth, 912, 905, 910, 895, 962. You've got an outlier here. You've got Enoch. But you know in Scripture he was and then he wasn't. God took him. All right. And we'll see what happens. All right. Methuselah, 969, the oldest man mentioned in the Bible. All right. Lamech, he died a little bit young also. And then Noah. Right? And these dates are sort of after creation, okay, following from there. Now, these are long lifespans for people, you know, hundreds of years. When I think about this, sometimes I feel what my body feels like now. I can't imagine living a couple more hundred years on that. But they probably age slower, too. All right? So that would have been interesting also. Now, this is supposedly before the flood. Okay, and if you add up the dates after the flood, all the way to Abraham, okay, you come to around 2000 BC for Abraham. Okay, so if this is from the beginning of the world to Abraham, well then you get an age of the earth of around 6,000 years, if Noah was, or Adam was made on the 6th day of creation. Right? It's a simple adding thing. You can do it yourself in Scripture, right? Biblical scholars have sort of believed this stuff all the way back, up until about the 1800s. And that's when the geologic ages started coming into play, and people questioned this a lot more. All right, so it was sort of standard operating procedure. Now again, there are some things that are kind of outrageous. Really, a guy lives 930 years? All right, yeah, that's a long time. Scientists tell us that we should be able to live a lot longer. In fact, everybody's trying to find that button, okay? Some things in your cells, like your telomeres, these sort of long things in cell division, that seems to be what shortens down. Some suggest, others are saying, no, it's over here. And there are scientists actively seeking and trying to make us live longer, okay? And in fact, in the last 50 years, we have lived longer. The actuary tables are there. My grandfather died when he was in his late 60s. That was about how long your lifespan was for a male in the United States back 30 years ago. Now it's about 82, so we are living longer, the average age. All right, and this is due to several factors, mostly food and medicines, okay, that we take. As you grow older, your medicine cabinet seems to expand, or at least mine does, and so I've got to keep understanding how to open those jars and put the pills in, these sorts of things. But we generally are living longer, okay? This is in contradiction to some people that say, the earth is dying, we're all getting polluted, we're going to die. Back in the 70s, it was a lot more of this. Everybody was going to be dead by the year 2000. Well, no, not really. In fact, we've got more people on the face of the earth now than we ever had. And it looks like that's going to continue for maybe another 30 years and then slope down a little bit. All right, so just looking at the genealogies and looking at when Abraham was. And Abraham, we can sort of set in history about 2000 BC. The biblical view seems to suggest that the earth is relatively young. Now some say, well, no, these chronologies, there are gaps in these chronologies, particularly a second group, because they weren't totaled. All right, and there might be, okay, I'll let people even have gaps there if they want to. But again, trying to match this up, for instance, with the evolutionary chronologies, would suggest hundreds of thousands of years old for human beings, it starts to get a little sticky, okay? You wonder, well, you're going to have more insertions and blank spots than you will people, all right? Well, yes, but these were meant to be, ancestors of and all that. And there are elaborate arguments on all these sides, all right? Generally, though, if you take it at face value, it indicates a few thousand years. All right. This is your biblical family tree, all right? Going through several generations. Here's Abraham and his kids, and going down, all right? We can do family trees just like we do genealogies today and see these sorts of things. We got Tubal, Magog. There's some great names back there, by the way, that we ought to resurrect, all right? I don't know, maybe Magog sounds just a little bit, I don't know, over the top. All right, but we've got a lot of good, we can follow genealogies all the way through, all right? I saw one person who believes they can follow it all the way back to Adam. I'm not sure about that, but there are some interesting things there, particularly in the King's List. This is the biblical chronology, all right? This is the genealogies of Jesus and Matthew, all right? This is what it says in so-and-so was the father of so-and-so, was the father of so-and-so. Again, chapters you usually sort of read fast because you're stumbling over things like Aminadab, this sort of thing. And then the Luke chronology, all right? The reason, for instance, some people say there are insertions is because in the Luke chronology we have two Canaans, all right? And the original ones we don't have that. There's probably explanations for that. And in fact, if you're really into the biblical chronologies, there are a lot of good references in a real nice article in here and some others that deal with that same sort of thing. It's called Coming to Grips with Genesis, Biblical Authority in the Age of the Earth. This approaches it from a biblical and sort of anthropological perspective. All right? But there's a good, nice long article in here on the chronologies and the different gaps and all of this. Apparently this gets into some elaborate scholarship.
Who's the author?
The author of this is Terry Mortensen and Thane Uri. These are the editors anyway. There's several contributors to this book. It's put out by Master Books. All right. Terry Mortensen's on staff at Answers in Genesis. He's done his work, his PhD work on the older geologists, what he calls a scriptural geologists, people who were geologists in training at the time evolution was coming into vogue and all that. Stratus Smith, some of these other folks, how they thought about the world, and then when all that changed. Okay, because it was a huge change in the late 1700s with Hutton's book on the Earth, and then again with Charles Lyell. With those two authors, they sort of changed the course of the nature of geology. All right? There were others who were trying to resist at the time, and then a lot of the theologians bought in the early 1800s. And by the time Darwin came along, the age of the Earth was lengthened hugely, actually. And then when he came along with the theory of evolution, it sort of cut loose. Now, there was sort of a limit on it. It was about 20 million years till about the end of the century. The history of this is kind of fascinating, actually, I think. The end of the century, because of what's his name, Lord Kelvin. Lord Kelvin talked about the heating of the Earth, and he said the maximum age of the Earth has to be this. And then at the turn of the century, in the 1900s, turn of the last century now, good night, they discovered radioactivity, and that allowed the ages to blossom into what they are today. The Earth's about 4.5 billion years old. The universe is anywhere from 12 to 15, some are even saying 20 billion years old, depending on who you talk to. All right? So that's a long time. Okay. All right. So from Abraham to now, about 6,000 years. From the flood to Abraham, a couple thousand years. Creation of the flood, about 1,600 years. These sorts of things. One of the criticisms that's brought up is the length of the days. Maybe the days were longer in Genesis. Well, that's fine. Even allowed for the first few days, perhaps. I think they're 24-hour days. I think that's the best case you can make for them. But again, you can't just stretch them out for thousands or hundreds of thousands of years.
And for one thing, the nights would have been a bit long.
The nights would be way too long, right?
Billions of years.
Weird things happen in the night. No. So the length of days.
Billions.
Some suggest a gap theory, that in between Genesis 1:1 and 1:2, for instance, there's a gap of unknown duration. God created the earth perfect. then there was Satan's rebellion or whatever, and then God recreated the earth. If you look at Genesis 1, in the beginning God created heaven and the earth. Something happened, and then the earth was without form and void, is what they say. And so there's a big gap in that area. And earlier, some of the folks were talking about Schofield. Schofield was a big gap theorist, all right, and some of these others, all right? And that's how they explain the geologic ages, because this really hit Christianity hard. Science was the up-and-coming thing. A lot of Christians were into science. In fact, if you look in the 1800s, people like Calvin, people like John Maxwell, or not John Maxwell, James Clerk Maxwell, and others were Christians. But this kind of thing spread, and I think part of it was the idea of we can get rid of a young earth, we can get rid of God also. In fact, some of Lyell's and even Hutton's writings seem to suggest that, again, get some of Terry Mortenson's books. If you look on the Andrews and Genesis website, he traces a lot of that history of the geologists themselves and the people, because people is what makes history and how these ideas change in your head. All right? So creation days, we think the days are similar. Now maybe the years weren't similar, some suggest. You know, the Jewish year was probably different. And that actually might be. They might have shorter months or whatever, but they would insert things also. Again, the problem eventually is if you don't do it, you know, correct your calendar every once in a while, you start getting spring in the wrong part of the year. All right? And the ancients weren't stupid. They realized this. That's why even as you see around the world, a lot of these guys were keeping track of where the sun was at a certain time of the year, and that told them that was how allowed them to reset their calendars a little bit. All right? You know, we reset our calendar back in, what was it, 15 or 1600s. There, the Pope, they switched it to today's calendar from, was it a Julian calendar? I can't remember right off, but they cut out a couple of weeks in October and got everybody upset. All right? So if you take the thing backwards. And again, what is a calendar? All right? The days are gone. We're just going around the sun, right? So we're marking places around the sun. And so we can say, you know, on this date in history, this happened. But really, the only tie we have is in our heads looking at our calendar. Because, for instance, at the end of the week, or beginning of next week, D-Day is coming up, right? The D-Day, I always like to remember D-Day. And the only real connection I have is it's the same date, but where we are in space and time, it's totally different. All right? Okay. Take all the time talking about time, don't you do that. All right, then we have the genealogies afterwards of, for instance, Japheth. Okay? Now, these are all pulled from, and I didn't bring the book, After the Flood by Cooper. His name is. Some of you probably have that book. It's a very interesting book. He looks at the chronologies, not only of Scripture, but of different people groups around the world. Bill Cooper was, I think he still is, but he was schooled or had the ability to go in several different languages. He's a British creationist. My understanding is when I talked to some people who said they knew him, that he knew Welsh and some of these other ancient languages and was familiar enough with the literature and things that sometimes if they had a question at the British Museum, he would go back in their archives and be able to pull it up. All right? Well, that's good if you could pull that kind of thing off. All right? Well, he assembled this book after the flood. Because, again, we're going to be looking at rocks and some other sorts of things that date the earth. But what's interesting, and I thought this was all lost, is when we get back into some of these other chronologies and things people have written down, they seem to suggest a Genesis kind of a flow to them also. They talk about these things. All right, so we have all these people, and a lot of people have gone to try and find where these different people groups went to, or different ancestors went to. And again, a lot of this is worked out in a lot of different books. There's another one I picked up, which is interesting. I'm not sure how much I like his scholarship. Bodie Hodge wrote one on the Tower of Babel. Okay, this is also for Master Books. And this delves into this whole area too, who went where, when, kind of a thing, and how do we figure it out. Now, what's really bad is while we have these ancient names, it turns out the Greeks were the one that sort of tried to change all the names, all right? if you read Josephus, he gets mad at the Greeks also, because he said, you know, they're doing stuff. And a lot of other ancient authors get mad at them too, apparently, in some ways. Okay? Like the old Soviets did, that tried to wipe out all history and these sorts of things. And that's unfortunate. And now we have some of the ancient sites in the Middle East there under control of ISIS. And they believe that anything before Islam just shouldn't be there. And so they're destroying stuff all over the place. All right?
Yeah, 19 what?
Okay.
Like historical documents, is that what they're?
Historical documents in cities, ancient cities, they're destroying. Okay? So it's like, why? What are you doing? All right? They've looted some of the museums down there and stuff, and all this stuff is pagan, according to some of the hardcore ISIS supporters. Again, they're heavily into Sharia law, heavily in all that. I think it's heavily satanic, but all right. They're wiping it out. Okay, that's never a good thing to destroy your history. But again, if you're Satan, yeah, that's what you want to do: cut off people from history. Like you asked them, that's what they're doing in the schools now. For the most part, people don't have any kind of historical. You know, like yesterday, I was watching the Battle of Britain. All right, I mean, man, that's a real interesting time in history to me. World War II, because you have a clash of ideologies, and you have a clash of nations, and there was really something going on there. But a lot of people, you know, that's those old black and white movies. You know, you can't get anybody to look at it anymore. All right, Ham. Okay, some of his chronologies out here, or genealogies. All right, and these are mentioned either in Scripture, okay, and Shem. Okay, all the way to Terah. And Terah was the father of Abraham. Very good, people. All right. And this is what you get from them. Okay, again, some great names. Moab. I always like the name Moab. I don't know why. All right. Hey, Dad. Okay, or Hadad. All right, some great stuff in here. All right, Isaac, and some of the names we're more familiar with. All right. Now, what's interesting is in some of other civilizations besides Scripture, you seem to have these chronologies, all right, or genealogies. This is the Irish genealogy. All right, so where do we get these from? Well, there's several books, and in the book After the Flood, he talks about these. A couple different places you go. One of them was a guy named Geoffrey of Monmouth. Spelling's not my first love. Okay, Monmouth. And he wrote Chronicles. It's a book on the Chronicles of the British people or something like that. All right? Should have put the title down there. Sorry I didn't. But what turns out is he said he was borrowing from some ancient books, and he put these things together in about 1100 or so. Okay? And for about 400 years, most people thought this was great scholarship, up until about the time of Henry VIII, apparently. And there was a scholar there who was working with Henry VIII, and they wanted to sort of rip themselves away from the Pope, if you remember the story, for various reasons. And apparently he said, oh no, these monks made all this stuff up, this is just hogwash and blah, blah, blah. And that's how a lot of scholars consider this stuff today. It's just useless. All right? Yes, sir.
One of the reasons it was discredited, it was mentioned in Acts and Facts, Chronicles, and it's in my book, where they mentioned Stonehenge. And one of the reasons they discredited it is because it mentions giants and dragons. And we know they're true.
All right. And so, yeah, those are kind of mythological creatures according
Yeah,
to
so it's got to be false.
Right. The Bible seems to talk about large people. All right. And, well, dragons, well, that's another lecture altogether, right? Okay, so yeah, that's some of the things they talk about in there. Now again, when you read some of these chronicles too, it isn't sort of a fanciful stuff. It's like, well, yeah, we came across one of these, it ate 5 of our guys, and then we had to go and kill it. So the nature of how they talk about it seems to be fairly realistic. And what some said then is, well, the monks made a lot of this stuff up. Which, of course, you're in a monastery, that's what you're going to do, is make up stuff, right? Well, perhaps everybody's a sinner, okay? I can understand that, all right? But there's some very interesting things when you start getting into it, and this is what Bill Cooper brings out. You can't just dismiss it out of hand because it talks about some very interesting events that we now can verify from history, all right? And they didn't know that kind of stuff otherwise until now or something like that, all right? Well, anyway, let's look at the genealogy. You got Noah, Japheth, Magog, and then it starts getting into, all right, all the different people that are in the Irish genealogy. All right, I don't know if you're going to be able to focus on these. I pulled these out of an online book of his. They have it online, and I didn't even know if it was going to show up here, to be honest. But it's very interesting. So you have it, and these people thought this was good stuff. Okay. Now, if you're going to be a missionary in a place that's never heard the gospel, and you pull out one of their old books, and it has this stuff in there, man, all right, a lot of your work is done for you, it would seem to me, all right? You can go all the way back, and oh yes, I know Noah, look, let me tell you about him, and let's look at what happened before. And of course, the big thing that happened before that everybody needs to be aware of is, and everybody tries to dismiss today, is fall. Right? The fall of man. There really was a fall and there is sin. Now I know you can't talk about that today. There's no such thing as sin. You choose what you want to be or whatever. You know, these things are options for the individual, okay? There really isn't any right and wrong. That's old notions of patriarchy. Okay? But according to the Bible, it says there really was a fall. And this started the whole thing spinning down, okay? That's why we old men have gray hair and things start to fall apart, all right? Because there's the fall, all right? Adam wouldn't have gone through that, okay? He was meant to live forever. And that's another area where people disagree, particularly in the earliest chapters of Genesis. The nature of the fall. Some of the early heretics were talking like that. The fall wasn't really physical, it was maybe just spiritual. All right, well, no. That's not how the Bible talks about it. And that's why Christ had to die, because of that. So it's really interesting how when you just dismiss the first few chapters, everything else kind of dominoes over. All right. Again, these seem to be, I would suggest, another young age indicator for the earth. If these are valid, and these people wrote this stuff down, this would suggest that this is correct, right? It's an anthropological way. I don't have a dating method here. I'm not looking at rubidium, strontium, or something of that nature. But again, these are old books that people have put together, and I love old books now, all right? And it seems to, you know, these are my ancestors, okay? I know who it is, and it doesn't go back very far. All right, it does. All right, the British Isles have these same sorts of things. When you get to Japheth, and you get to all of his sons, and then they start listing right under there who they are, okay? Now, you can't go to a book that's there and see all this, but it's in some of these older chronicles that these gentlemen put together. Geoffrey of Monmouth and some others have assembled, all right? A lot of this was dismissed after Julius Caesar conquered the British Isles, okay? And some of the stories that are in there are from the British perspective, which is really interesting, and another reason why a lot of these might be valid. They're seeing the Romans come, and so they're fighting them in various ways. What people are saying is, well, you know, what's interesting is they don't mention the Roman techniques or their techniques for fighting the Romans. But again, the chronologies or these books weren't put together for the Romans, and the people that were reading it knew how the fighting techniques were, so they didn't put that in there. It suggests a genuinity again of what was going on. All right, we got them all the way through here. There's some really good names down here. You know, the Wologoths and stuff like that. All right,
Vandalism.
yeah, and again, the Vandals were part of the groups that attacked Rome in the end. All right. Chart showing early British kings. Okay, so these are the kings. Now, this guy Brutus is very interesting. He's got, he was one that looks like was involved in the sacking of Rome in about 500 BC, or a little bit before, perhaps. All right. He's also mentioned. Let's see if he's in here yet. Biologist, okay, yeah, we're looking at a lot of them, and again, it gets big. These are going into what we lose already. But you also get into things like Arthur, okay? Now, Arthur is thought to be basically all legend by a lot of people, but it's in a lot of these books, okay, as being partly in the line. Yeah, he's holding his thumb up there too, all right?
Chronicles talk about him and Merlin, and they ignore that.
Yeah, because everybody thinks it's a myth, all right? No, I don't know if the whole other thing about that is...
The legends are a bunch of baloney.
Right.
Now are
People
these
probably existed.
dated, and what are the dates for these figures?
It depends on the people. I think the Arthurian things are what, 500? Maybe a little bit before? Okay?
BC. Yeah.
500 BC.
Mhm.
Yeah, so they go back actually a couple thousand years. For instance, Brutus and some of these others, when you start getting into them, all right after Japheth, you're talking probably 1800 BC or so.
Okay.
And so they think they have continuous lines through that. Okay, again, that book, After the Flood's a real good read, particularly at night. You sit there going, really? Is that true? Really? Okay, because it's an interesting, he makes the case better than I am right now with my put together PowerPoint that fell apart. All right. What I'm just trying to suggest to you here is there does seem to be, outside of Scripture, similar things that you see in Scriptures, like the genealogies. All right. Other people have written them down about themselves. Okay. And again, today these are dismissed for various reasons. One of them perhaps might be that these seem to suggest a very young age for civilization. All right. Linus. Okay, the Norwegian kings, they seem to trace themselves back pretty far. All right. Looks like I messed up and didn't put the top one on here. Okay. But they seem to trace themselves, a lot of them trace themselves back to Noah, or at least Shem, Ham, and Japheth is what you get. And that's kind of what you'd expect. The Mao people, and I don't think I have that one in here, trace them back to, well, the first one is called dirt, which is really interesting. Okay, again, they had them made out of the dust of the ground, this kind of a thing. So there does seem to be some just a lot of interesting. Let's see, asking a British descent. No, it doesn't have Merlin. So this is even before that. Okay, the British Islands were stormed by Julius Caesar. These sorts of things. While the monks were killed, there was a couple of different things going on there. But they seem to have been populated for quite a long time. The Royal Saxon House, and these get into Woden, down here, Geet, and some of these are talked about in history. Look, there's even a king named Bubba. Yeah, you just never know what you're going to come across in some of these names. All right? But what I'm trying to show is just the fact that these lineages existed. People said this person was there, this person was there. Now, of course, everybody could be lying, okay, for whatever reason, all right? You have to assume standard conditions, and maybe there could be lies, or they could be just doing this stuff, or whatever. But it does seem like one of the few things you want to remember is who was in your lineage, all right? All right. Let me see this down all the way to the House of Northumberland. Okay, so these are part of the House of Kent. Okay, they're tracing all their lines, and you can follow a lot of these kings. Again, the book After the Flood has these in a better form. Okay, and he systematically goes through these, giving reasons why he thinks these have more validity. Now, one thing he mentions in that book, is a paper by Flanders Petrie. Flanders Petrie was a great archaeologist, late 1800s, early 1900s, and he wrote a paper on this, that these things, in about 1917, these things are too easily dismissed by modern day scholars, and they shouldn't be. All right, now I haven't gone back and tried to find the paper, but Bill Cooper, in his book, After the Flood Again, outlines these things and suggests Petrie's reasons are correct, that these things should be taken more into account. And they're sort of dismissed now, because I think a lot of it is that they're too close to the biblical view, and that would be considered just, that's why they did this. These Christian scholars went back and put these lineages together to match the flood or something like that. Okay. According to the secular community, time is in fact the hero of the plot. Okay, given much time, the impossible becomes possible. And the possible probable, and the probable virtually certain. Only one has to wait. Time performs the miracles. All right. Okay, there you go. You can believe in a miraculous God or a miraculous time. Now, this quote is in relation to basically the origin of life, okay, and the origin of species, basically. That if given enough time, these things can change from one to another. All right, the creationist maintains no, time is not the hero of the plot. In fact, if you've read some of John Sanford's work, he does a lot of work in genetics and all of that, suggests that the genetic load on the human and other species around the earth is building. And when it'll go to what we might call senescence or falling apart is another question. But each one of us has a lot of mutations built into us. All right, and every time we have a child, there's lots more put into the human gene pool, so that we're all lugging this stuff around. Now, the interesting thing, the way God made things, it still works, and we're still lugging around, although we do see diseases now that are related to genetic mistakes, okay? And we've got a catalog now of all these sorts of things. One of the girls that used to work with me in the museum had cystic fibrosis, which is a genetic disease, an inherited genetic disease, and she passed away while she was working in the museum with me. Just a wonderful little girl, maybe 22 when she finally died. But your lungs basically sort of crystallize and you can't breathe anymore. All right? Terrible genetic disease, and nobody's been able to find a cure. Though people are running at these things, they're telling us now that medical knowledge is doubling every 5 years, which is good. So if you live long enough, you get a good chance. But, the longer you live, the better chance you get, I guess. All right, for all these things. Okay, so time, according to the evolutionists, is the hero of the plot. But the Bible says a little bit different, that there is a certain time in history. The Bible talks about linear history also. Okay, this king was then, this king was. Now, a lot of times you hear, for instance, the Lion King, the circle of life. Okay, some of the Eastern religions are more like this, that time is in these giant cycles. Okay, the Mayan calendar was like this. Remember that when a couple of years, 2-3 years ago now? The end of the world, right? With the Mayan calendar. What was that film? The Day After, or something like that, was based on that. The whole thing. Okay, well, it didn't happen. The Mayans were wrong. Okay, cool calendar with the tongue hanging out, but not going to happen. Is it in cycles? No, the Bible says it's linear time, and there's going to be a time of the end. Okay, when that is, can't tell you. All right, God said He's not telling anybody. All right, there are some interesting things on the horizon that look interesting. Okay, we are facing all kinds of it looks like calamities almost.
Now, as far as time being a hero, they forget about entropy. The more time, the more destruction.
Entropy is a big thing that we've talked about.
They forget all about that.
Second law, right? That things are winding down. Okay, that's why you wind down. Entropy, you've got to regenerate.
The less chance of adaptation,
It
the
does
longer
seem
it
like
lasts.
You build up mutations, and or genetic entropy. There's entropy in systems. Now these were first put together by thermodynamics when we started building steam engines a couple hundred years ago. They realized that when they put the coal in there or whatever they were using as fuel, a lot of that went out as heat, and so they had to calculate how to build everything in relation to that. And that's some of the first thermodynamics and all that were some of the 1800s scientists who finally figured all that out, and we use those kinds of things today when we're building engines and all that sort of things also. But it does seem to be a general thing. The universe is kind of running down. The physicist or the astronomer or the cosmologist looks for the ultimate heat death of the universe, and everything will just be a sort of vibrating hum after a while. All right? And that could be, unless there's a God behind it who's doing stuff with it, I think, and who isn't subject to entropy like we are. All right, God said He made everything in 6 days, okay, and rested on the seventh. Now, these could be long periods of time, according to some. But again, if we just take that at face value, all right, 6 days and he rested on the seventh. We are reading in a church that emphasizes that also. All right, Yom is mentioned in the Bible, some of the Hebrew things that are talked about. Now, while some believe that these are long periods of that, even in this book they mention and they talk extensively about Yom and what's going on there. All right, some of these slides are from the presentation. This is just to show that there is a sort of, not contradiction, but a fight in between what's really going on there. If things evolved the way they did, then evolution-wise, for instance, better existed than land, than marine organisms. Scripture seems to say just the opposite. So trying to oppose the evolutionary view onto Scripture isn't a problem. Dr. Ross has overlapping days in his theology. Davis Young, John Morris put this together. A little bit more overlapping, if you say. Okay? All right. The Bible seems to suggest a very young age. Okay. Let's look at some other evidences that suggest a young age, according to creationists. And these are a lot in John Morris's book, The Young Earth. There's been other subsequent volumes of people putting together that talk about these things. And again, what I usually like to say is I'm making the case for it. These things seem to suggest it. They all have these built-in assumptions. We assume a constant rate. We assume initial conditions, these sorts of things. And any one of those can be wrong. But just assuming what's assumed, for instance, with radioisotope dating, let's look at these. Wind-up times for galaxies. Okay, you've seen pictures of galaxies now. Go on the web, look at the Hubble telescope and what it's looking at. It's an amazing universe out there. It's just beautiful, all right? Or awesome to look at. I think we forget that a lot of times when we're looking at the universe, especially as science types, we have a tendency to make everything, into a mathematical equation or something like that. But that just looks cool, doesn't it? I mean, I think it does. If I get to heaven and God remakes the universe, I'm going to visit some of those, if I can, okay? Just to see what's there. Now, I don't think there's any aliens out there. All right, that's another lecture altogether. Like I said, I used to get people coming in the museum who told me they were from other planets, but I don't think they were right. Okay? Supposedly 10 billion years old for the galaxy, but there is a problem. Okay, when we look at the galaxies, they're rotating, a lot of them particularly, all right? And the way they're rotating, it's going faster along the edges than it is around the outside. So in a few rotations around, it should wind up tight. How long does that take? Studies have been done on this. If you can get this book and The Origin of the Universe by, what's his name? He wrote it at ICR. Okay. No. The astronomer, Danny Faulkner. Okay, he's got a good book on astronomy, and I'd recommend that one because he goes through a lot of the different things and talks about Big Bang particularly and why it wasn't as predictive as everybody says it was. All right? But as you do these simulations, if you took all those arms out straight and started winding them up just like we see, okay, after about 1 billion years, the wind-up starts to begin. Okay? And only after about 3, you get galaxies that look like this, or about 300 million years. And this is what you see, similar to what we see today. Looks like the wind-up times make it very quick. Maybe in 1 billion years, you'd wind all these babies up. All right? If they start at the beginning of the universe, and a lot of these galaxies are presumed to for various reasons. All right? So if we have this, now, several things have been put forward, things like gravity waves and all of that. And I won't get into the nitty-gritty of all that, just to say, okay, so there have been things put forward. But this is also why you see a lot of the dark matter push, I believe. Okay? Because there's got to be something that holds a lot of this or does this together, and it's just not there. We can't find it. Okay, so it's dark matter you can't see. Well, that's good. All right. How do you figure it out? Well, you can maybe do some various testing and stuff like that. And this is another reason they're taking all these batteries, jammed it into pieces and looking for these exotic particles also. Anyway. All right. Spiral arms are tightly wound. Many theories since the 1930s.
So can I jump into, like, the evidence there that you presented still doesn't get close to 10,000 years.
Right.
But you're off of the 10 million into what, 3 million?
Maybe 300 million.
300 million. Okay, sorry.
Okay. Yeah, that's not 10,000 for sure.
Okay.
All right. But what I'm showing you is if we assume a constant rate and some of these other sorts of things, like are assumed in some of these other dating methods, we get far younger than the billions of years that are supposed to be for these. What I'm trying to show is the dating methods all have assumptions built into them. When we look closely at some of them, we get some real issues. All right? Why? That's supposed to be 10 billion years old. How come it winds up that fast? Well, there might be something we assume. We're assuming a constant rate of windup. That might not be the case, and that's what the evolutionists will say until they hypothesize several things.
All right.
A straightforward look on it, though, suggests a younger age for it. Okay?
Younger than 10 billion.
Then 10 billion. 300 billion is less than 10 billion.
Yeah.
Okay? By a huge factor, actually. All right? So if I can bring stuff down to 300 million with the stars, wow, that's not enough for Big Bang. Okay? Okay, so I'm just showing you things that show younger, or when we take certain assumptions.
Okay.
So I'm not trying to get to 6,000, 4004 BC like Usher, 9 a.m. in the morning or something like that.
Could someone say that that's evidence that it can't be 10,000 years old?
Perhaps, yeah.
Okay.
And that's a big question, actually. The second biggest we usually get at ICR, starlight and the age of the universe.
Right.
Okay, if the universe is that big, how do you get light from
10,000.
what's going on there? All right.
Yeah.
And this is where Humphrey's work comes in. Dr. Russell Humphreys wrote a book called Starlight and Time. And he's actually, I think a lot of people here have probably seen it. It's a cute little book. And he's done some other stuff on the internet now. He's got some new theories of gravity that I'm trying to work through. Dr. Humphreys was at, Los Alamos, wasn't he? Los Alamos or San Diego?
San Diego.
Yeah, and he was involved in a lot of things, but he operates like a theoretical physicist. He's a real nice guy, okay? And he's been doing a lot of work with relativity, general relativity, and special relativity, looking at it from a young Earth perspective and looking at some of the things there. We're going to see some of his work coming up a little bit, all right? Okay. Okay, so that's what I'm trying to put. Okay. All right, supernova remnants. Here's another one. Stars explode, supernovas are big stars. They go poof, and we see a lot of them. A lot of them are pretty. This is one of my favorite, the Crab Nebula. The Chinese actually observed this baby crab going off. All right. If the universe is billions or millions of years old, there should be a certain amount of supernova remnants. Okay. There should be lots of them actually, because they seem to occur. We can statistically look at these things. The amount of supernova remnants that are observed suggests the age of at least around our galaxies and stuff, and close to about 7,000 years. Okay. Now, there could be more we haven't found. Blah blah blah. This kind of a thing. All right. But there should be a certain amount according to this thinking. But when we look, it's deficient in this area. Okay. Again, these are talked about in I believe Dan Faulkner's book on the origin of the universe, that sort of thing, and they're talked about more. All right, short period comets. Comets are very interesting. They're like big ice balls with rocks in the middle. Okay. Every time they come near the sun, they lose pieces. They get that big tail that goes around, that sort of a thing. There are two kinds of comets, basically, long period and short period. Long period, come and go, we really don't see those again. But there are some short period comets. Some, perhaps the most famous, is Halley's Comet. All right, comes around every 76 years. Mark Twain was born one and died when he came back the second time, this kind of a thing. So Halley's Comet's got a lot of fame. It's called Halley's Comet because Edmund Halley, a friend of Isaac Newton, Okay, was the first one to sort of predict when it was going to come back. You seem to look in the literature and all that. Well, it turns out every time you come near the sun, you lose pieces. All right, come back around, lose pieces. And what people have done is they've looked at this and suggest that short period comets, because of the nature, you can only get a comet so big, apparently, and they're falling apart at such a rate that they would have maybe 10,000 years before they should all disintegrate. Okay?
Comets in general.
Short period comets.
If they're a certain size, they become planets? Is that what? or
No,
stars, or-
they can't exist after, I believe they can't get bigger than a certain size, because they're made of ice and all that, and you need a core or something like that,
Gotcha.
okay? And so they're saying that they can't last any more than 10,000 years. Now, there have been explanations for it, okay? They suggest that there's an Oort cloud out there beyond the edge of the solar system that seeds these things in. That's a good, interesting idea, and it might actually be, but it's not observed. Okay, so we want to stick to what we know. All right. Collisions. Okay, the Kuiper belt, and there's actually been some pieces of the Kuiper belt actually observed, but it drains too fast. You're not going to have enough comets up there apparently for the billions of years that the age of the solar system is. Okay. Now, again, these other books work these out in more elaborate views. What I'm just trying to show you is there are some things that perhaps point to a lot younger age of the solar system, perhaps on the order of 10,000 years. Again, if we assume constant rates and these sorts of things. All right? Now, there may be other factors we don't know. I'm just saying that there are things out there that maybe suggest something younger. All right? Because generally the idea we get is everything says billions of years old. Okay? The rocks say it, this says it, that says it. That's not necessarily true when you look at some of these processes. All right? This is a good book to look at some of these things in here. He talks about a lot of different processes. And again, if we look at constant conditions, rates, and some of these things suggest a younger age for the Earth. Let's go through some of these. Salt in the ocean. All right? Ever been down the Pacific Ocean and get a mouthful? That's good, isn't it? Yeah. All right, I remember we used to take trips to Florida when I was a kid, and I remember the first time I got a face full. Whoa, Dranger, yeah, man, it really cleans you out. Okay? Yeah, makes you breathe all the salt in the ocean could accumulate, okay, sprays onto the land, coming off the land, erosion, all this sort of thing, in about 62 million years. All right, again, we're looking at our constant rate. We assume no salt on the continent or in the ocean floors. All right. We assume the rate we're watching now. Okay. Put that in there. You get an upper age of 62 million years. Now again, that's longer than 10,000. I understand that, but it's also less than 4 billion. All right. When you say, well, yeah, because during the time some of these stuff and this came out. All right, fine. I understand that. I'm just talking about a constant rate and what we're looking at. Okay. Erosion of the continents. At the present rate of erosion, when you calculate how much stuff falls into the water all day long, all right, we could erode all the continents down to the ground in about 14 million years.
To sea level.
Right. Now again, it's not 6,000, I understand that, but 14 million is a lot less than billions, right? Now what would you counter with that? Well, there's being uplifting and all that. All right, I understand that, okay? So our second assumption here, a constant rate and all that, isn't exactly true. Particularly in California, we know things move around, all right? We're sitting on probably one of the most active faults ever. And I just saw another TV program, we're all gonna die soon, so. Okay. Get to know Jesus if you don't, or, whatever.
Is that my fault or your fault?
Nah, very good. All right, earthquake jokes. All right. Okay. Accumulation of ocean sediments. There are sediments on the bottom of the ocean. At present rates, all the sediments can accumulate no more than 14 million years. All right? All the junk we see on the bottom. We just scrape the bottom clean and just let it fall in there. All right? It's not as much stuff on the bottom of the ocean maybe as you think. It might be thicker in some places, but we know there's actually trenches that go way down too. All right? Yeah, the ocean is still a rather mysterious place. All the World
And
War
the
II.
trenches can't be too old because they didn't fill up.
Yeah, you would think they might fill up, although there might be some kind of weird currents there or something, I don't know.
Yeah.
I don't know. Or they might be recently opened up. Okay, I can see that. Like the Marianas Trench is the deepest. It's what, like 7 miles. All right, don't go there. Okay, without a floating. Okay, now we come into the ones that a lot of people like to talk about. Your decay series. This is uranium into lead. Now, what's going on here? Well, certain elements are very big. They have a lot of protons, neutrons attached to them, electrons. And what happens is they are radioactive. Radioactivity, like I mentioned, was discovered around the early 1900s or so. And a lot of people started playing with them, not knowing exactly what they were doing. One of my favorite is this one, polonium. We're going to look at polonium a little bit. Madame Curie was the one who worked a lot with polonium. Madame Curie Skłodowska. What a woman, okay? 2 Nobel Prizes. And if you look at the 1927 Congress on World Physics, there's all these men, and she's right in the middle, and she looks like she can take them all. But anyway, all right? See these decay chains. What happens is alpha particles come off, neutrons and protons together. They come flipping off these things. That's what gives the radioactivity. Radioactivity is very bad. These bullets are coming off like the speed of light, and they cut through everything. So when you have radiation poisoning, you basically bleed from everywhere. It's not a good way to go, okay? And we've seen a lot about this now because the president was just in Nagasaki, Hiroshima, all right, and they're talking all about that and the people who died there and all that. And yes, it was horrific, okay? But I just remember, it was about 2 years ago when Dr. Gish, one of the famous creationist scientists, passed away. They had a memorial down in San Diego where he lives. And Dr. Gish was in World War II. He was a forward spotter. He'd sneak under the lines and see what was going on in the Japanese theater, the Pacific. And he and his men were there. They just finished a lot of their work, and then they realized that the call came out that we're going to invade Japan. And he basically made a speech to his men. He said, "Look, guys, the nature of how many casualties they think and stuff is going to happen, I don't think we're going to make it back." Right? That must have been a sobering moment. Okay? So he said, yeah, when they dropped the bomb, it saved us, in a sense. It also saved a lot of Japanese, too, by the way, because they thought the casualties on their side would be 1 million or more. All right? Because of the way they had fought along the islands and all that kind of thing. We don't have to get into that, but all right. Okay, anyway, this is a nuclear decay chain. Uranium-238, which is what we wanted to do to get the bomb, actually. We did a lot of interesting stuff with that. You could read about that story during World War II. Falls apart, decays, and eventually turns into a stable element, lead. Okay? You know about lead. You're not supposed to be around it or even touch it now because it's going to kill you. All right, and it's bad, no doubt. I'm not sure it's super lethal in the same way that everybody's talking about it, but we're scared of everything now, it seems. All right. So this is part of it. These are the nuclear decay chains. You see these little alpha particles going, wee, 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 wee. And what happens when you get rid of protons and neutrons, you actually change the nature of the element. So it turns from uranium to lead. Okay, now if you're a mad scientist, you're over there, wow, what if I could do the opposite?
Into gold.
All right, well, we did enrich uranium, okay, but it takes a big plant to do it. It's very costly. And you got to know what you're doing, otherwise you get yourself killed. All right? What they're trying to do in Iran right now, by the way. Stay tuned. Okay. Another young age indicator. The Earth's crust has a lot of uranium in it. Now, when uranium decays, like we saw back here, these alpha particles, in a sense, because they're 2 protons and 2 neutrons, basically are helium atoms coming off the thing, okay? We can, when we look at the Earth's crust, see how much uranium, we can make an hypothesis on this, and see how much helium is coming off of this. It's the helium escape problem, basically. The atmosphere holds a lot of it in, some escapes, but if we wanted to use it as an age indicator, we could measure how much helium was in the atmosphere. We know its permeability, these kinds of things. We have an idea how much uranium is in there. We could perhaps get an age of, say, the Earth's atmosphere anyway. And when we look at this, assuming constant ray conditions, we get a maximum of 2 million years. Now again, none of these suggest that it's right. It's just a lot younger than Bill. Inquiry, was somebody, inflating a lot of balloons and letting, I don't know, these kinds of things. Where did the helium go, kind of a thing. All right. Okay, my assumption, or what we'll talk about here, if the flood made the rocks and fossils and the geologic ages, or most of what we see in the geologic age, is made within a year, then there are no geologic ages, all right? And so this disappears. The question is, can you do that? That's what the Bible talks about. If you read in Genesis, it said Noah got on the boat, got all the animals on there, okay? You've seen the recent Russell Crowe movie about Noah, right? Yeah, you might not want to. It's based on some heretical documents. But anyway, it's got some interesting scenes in there. He's got all the animals. Now, it turns out Noah in this movie is a genocidal maniac that tries to kill his kids and basically got everything out of the ark because he wanted to save the animals in hopes the people all die. Which, wow, what chapter and verse is that in? Okay? At least do the story straight. I know you think it's ridiculous. But anyway, an atheist apparently put that movie together, which, duh. All right? But according to the Bible, if you add up all the days in Genesis 6 to 9 there, 40 days and 40 nights of rain, the water comes up another 150, then it goes down for another 150, then they went in the ark for 40 days, and then you get to about, 370 days for the nature of the flood, the length of the flood, okay? That's about a year. Creationists maintain that a lot of this was probably laid down during that time. Let's take a closer look. Predictions, we would say. Catastrophic deposition. And again, if we're right, we're looking at layers in the ground, and we think they can be laid down catastrophically, or we can make a case for it. That shortens the age of things, you understand? Because most of these rocks are things thought to take a long time, depending on the nature of the rock, for them to be laid down and represent different geologic ages. All right? Okay. Regional stratigraphy, we would predict. Now, what does that mean? It means that rather than just in a local bed area or something like that that you find, you'd find these things covering vast areas of the country. All right? So you get stratigraphy that'd be all over. That's what we'd expect perhaps from the nature of the flood. It would cover large areas. Okay? Because you've got a worldwide flood, right? I mean, you're really kicking stuff around. Deformation of sediments before hardening. Okay? Would suggest then what we predict from the flood. This stuff's all laid together, it's still soft, and we get taffy movement, basically. And that would suggest that all the layers weren't hard at the time they were laid down, some of which differ in geologic ages, supposedly. But if they were all still soft at the time when they were deformed, they couldn't have been there that long. They would have dewatered, or various other chemical processes would have come along. All right? And rapid canyon erosion. We expect stuff to be rapidly eroded, along with perhaps inconsistent dating results. We're going to try and take a look at some of these. Let's see, National Geographic's most catastrophic in all time, the natural phenomenon, started looking at tsunamis, and he found historic tsunamis, somewhere it's upwards of 1,000 feet high. Now again, usually the rule, ever since Charles Lyell in geology, is what we call tidal waves. Okay, if you don't know what tsunami is, you don't pronounce the T. It's just the way it goes. All right, it's just like in French, you don't pronounce the T at the end of ballet. Okay, so here you have a front T that's silent. In geologic circles, time Charles Lyell or maybe even Hutton before him, the idea was that these layers took a long time to be laid down, and that as you looked at different layers, you're looking back in time. Okay, and that this was what built up the geologic time scale over, over a short period of time, over a century. The Earth went from just a few thousand years to millions of years old. Okay? Okay. Hurricane, the flood, tsunami may do more in an hour and a day than ordinary processes of nature can achieve in 1,000 years. Geologists now are looking more at catastrophic geology. All right, this has come more into play. Derek Ager, in his book, The Nature of the Stratigraphic Record. Now, he is not a creationist, he is an evolutionist, doesn't like when we quote him, all right? In other words, the history of any one part of the earth is like the life of a soldier. It consists of long periods of boredom and short periods of terror. Well, if the flood was really what happened on the face of the earth, that's sort of similar, okay? It's a long period of boredom, 1,600 years, and then boom, you got the flood going on, and it's terror all over. The ultimate terror so far, okay? Friday the 13th, all those. Nothing compared to the flood, all right? You're drowning everything, okay? Ground's ripping open. I mean, there's no place to stand. Now this one crazy dude builds a boat, but you can't get in because God locked the door. So you're done, all right? Okay, we see various things now as geologists are taking more and more of a look at these things. Things like turbidites, large underwater deposits formed by catastrophic water currents. One of the most famous of these was sort of documented in a sense, or these were starting to be looked at when they started building the big transatlantic cables, you know, to connect the new world with the old world, and telephones, because people have to talk to each other, all right? And what happened once is there was a big earthquake on one of the continental shelves. And what they laid several cables out that way towards England. And what they found is after this big earthquake happened, there must have been a gigantic underwater landslide. Later on I looked at it. And what the landslide did is it slowly went across and it snapped each one of those cables in turn. And the time when all the cables snapped, they could estimate how fast that baby was going. And underwater, these things could go 60, maybe more miles an hour. Okay, underwater. Okay, so you don't want to be around one of those for sure. But we see these kind of deposits then we start looking at various places on the earth. Okay, 60 miles an hour, 430 miles, covered an area of 440,000 square miles. So you can do stuff really quickly if you have the right kind of condition. So stuff may look old according to what we see now, drip, drip, drip. But if you look at the processes and study it further, you find out it wasn't a drip, 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 but okay, and everybody's going out for it, okay? We see this in the geologic record. Let's see. 1/3 to 1/2 of all sedimentary rock now found on the continents can be interpreted as turbidites, okay? Fast flowing stuff. Dr. Austin did a lot of work with, I guess you would call a turbidite in the Grand Canyon. There's a nautiloid layer on the red wall, just below the red wall, I believe now. And nautiloids are these big sort of cone-like things, octopus and shells, basically. They're not around anymore, because we don't think so. But what he found was a layer of these things, and they're laid down in a certain direction and all that. Anyway, from the nature of how these things are laid in there and fossilized, you can calculate things like speed and all that. And it looks like you had one of these turbidites come in and do a giant nautiloid kill. And it goes throughout the canyon up into Arizona and up into Nevada a little bit and these kinds of things. So it's a giant turbidite kill, or nautiloid kill based on turbidites. Okay? Now, this doesn't give us an age for anything, but it suggests things that we thought looked old can happen quickly. So the place then, if a individual layer happens quickly, all right, we've got a layer here. Say we have layer A. I'll do this in a, sort of mathematics. And we have layer B. Okay. All right, and we have layer AB. Let's just go there. This one we know is laid down quickly. This one we know is laid down quickly, and this one we know is laid down quickly. Well, a lot of people were saying yes, but these layers are, maybe 500 million years of evolution. Fine, but if this layer is laid down quickly, this layer is laid down quickly, and this layer is laid down quickly, where is the time? In between the layers. Well, that's good, but that's not an argument from what you see, it's an argument perhaps from what you don't see. Okay? All right.
Do we want to say anything about how clean the layers are in between? That line is...
Well, that's what we see in the Grand Canyon. We do see that. There's a nice knife edge in there. Again, if these layers were laid down quickly and there was a lot of time in between, we might expect to see erosional canyons and other things in there. That's just not what we see, it seems. Okay?
And even for those really big layers, the divisions are down to the fraction of a millimeter.
There you go. So you have, what you have is people or ideas that suggest, you used to think would take billions of years. That's not coming up so good. Dry erase. All right. Again, something that suggests perhaps a little younger, all right? Or we get rid of some of the time. All right. What time is it, by the way? We don't want to take too much later. All right, this is Mount St. Helens, okay? What we find here, when Mount St. Helens blew off, it did a lot of interesting things. Cut canyons real quickly, laid down layers real quickly. In fact, it laid down all of this. Now, what's interesting about this is this was pulses of the volcanic eruption. If you look at this from a sort of old Earth view, perhaps, or something, you might suggest, because these different layers are here in laminae, this might have taken a very long time. But we watched it happen, so we know it didn't. Things that we think would take a long time can happen quickly if you have the right cutting conditions. This doesn't necessarily get rid of all the age, but what I'm saying is when we look and find similar stuff like this in the geologic column, it might compress the age a lot. All right? Okay, micro layering. I mean, we have mini pulses here. I mean, look at the stratigraphy or the strata that you see there. That's incredible. Nobody thought that that could happen until we went back and looked at it. Now, it turns out there was another guy named Guy Kalt who'd been doing work on this and it actually had formed this kind of stuff. But based on this now, it sort of changed a lot of views. Mount St. Helens did a lot of interesting things there. Okay, we see these same sorts of feel to some of the limestones and some of the sandstones in Grand Canyon. Okay, now admittedly they're bigger, but again, if the flood was worldwide extent like we're talking about, we're going to get big layers. Okay, can we do it rapidly? Well, the suggestion is now maybe we can. But just because a layer is big and sitting there didn't necessarily mean it take millions of years. We could do it quickly, again, if you have the right conditions. These are weird things. Okay, sometimes you get trees fossilized. Okay, and you can see this is a tree. You can go up to it and you should look at the microstructure. It's very interesting stuff. All right, but you'll notice this tree is vertical. Okay, and it's sandwiched in all these nice little layers here, which are wrapped around it. Okay, suggests that this was all laid down at the same time. Yet, if we look at some of these layers, we've got at least two, maybe three major geologic differences here. Okay, maybe 15 million years separates those two. Question: does it really, or does something like this sticking through all those? Looks like it was buried in situ. All right.
What's the old Earth response to that? What's the old Earth response to that?
Well, I'm not sure, because this part's in coal, this part's in shale.
Yeah.
They would say perhaps it was a later intrusion. To be honest, I'm not sure. I haven't looked at this one particularly. Polystrate fossils are very interesting things.
Yeah.
Okay? It does seem to cause you to think at least anyway.
Yeah.
Okay? Now, the weird thing about some of these is there's no
Dig it out,
roots.
put a
I think that
carcass
they say
down there.
that, because I've read some of the websites, I think they say that for some mysterious reason that while I guess the bottom of it is buried, the rest of the tree fossilizes above ground for some reason. It just waits there for 15 million years for the next.
It's true, but then you get erosion working on
Yeah,
a tree, so you have to take that into account. All right?
And then they
Now,
say
maybe-
it's a desert or something.
Okay, yeah, so yeah, you don't have any
Sand.
water. Okay, that's fine.
Sand around
We
it.
know I'm the Mojave here, that's where I work. Things can last a long time. All right, so you can mess with the assumption.
Millions of years.
Fine, okay. Now, there's some of these, like in Yellowstone and all that, they're fossil forests buried on top of each other in multiple layers,
Yeah.
okay? And those are very interesting because they stick through some of the layers. Now, the weird thing is they don't have any roots, okay? So it looks like they were transported in and sort of similar to what we see actually in Mount St. Helens. There in Mount St. Helens and Spirit Lake, these trees got ripped off, started floating around, okay? The root balls would sink, poof, poof, and they would sink at various times as sediment was building up in the lake. And it was like, wow, we're watching Disney unfold, all right? Just like we see in some of the fossil record. Is it the same? Maybe, maybe not, but it is very interesting, isn't it? A catastrophe could do the same thing we think might take millions of years. Because what they say, for instance, Yellowstone, those are multiple fossil forests, okay? When what it looks like is multiple fossil forests ripped out of their foundations and buried. And in Yellowstone, it's big, all right? Up there, you've got, Yellowstone? Not Yellowstone, well, in parts of Nevada, not Nevada, Utah, you've got one place there, I think it's near Bryce. I haven't been there in about 15 years. There's checkerboard mesa. There's sandstone. Okay? And what you see is cross-bedding.
Zion.
Okay, yeah, Zion has the cross-bedding, that's right. Okay, you see a lot of this thing's going up like 2,500 feet. It almost looks like you're taking a Polaroid picture. Polaroid, tell me the old age.
Dated yourself there.
There we go. See, date. I can date myself by the types of things I remember. All right.
Older.
And as my memory goes, I won't be able to date anything. All right. That's fine.
Yeah, well, windy.
It looks like we can calculate flow and how you would have to get these. And it suggests a lot of flow quickly, and then it's solidified. Okay? All right, I'm making a poor case for some of these, but these are developed a lot more in some of the books, okay, with relation to this. All right, so there are things like polystrate fossils, again, coal, shale, two different things, all right? Interesting, more difficult, go ahead.
You age even quicker after you peel the paper out.
Okay, good. Okay, here's this one John Morris used to do. It's called Limestone Cowboy, all right? Notice that these are cowboy boots, circa 1890, maybe a little later, okay? And you've got fossilization. This is just to show that a lot of people think that in order for something to become a fossil, it has to take a long time. This is how you're taught in all the dinosaur books and maybe all the Discovery Channel stuff. But it turns out you can do it quickly if you have the right kind of condition. In fact, you generally probably have to do it fairly quickly because we know things rot, fall apart, and they're gone. All right? So however those things get there, like dinosaur bones even, okay, it probably has to be very quickly. Particularly now, go ahead.
So what are the conditions to do it quickly? Like a volcano, or, I mean, is
Yes.
it pressure?
It's not pressure
Organic.
necessarily. It's, for instance, maybe in,
Silicon.
okay, it's got to be something that has calcium in it, maybe. All right, so maybe he's in a river, or these are found in, died in a river that's got a lot of the kind of deposits that would replace the skin or even the flesh with some kind of mineral deposit.
Oh, that's human bones in there.
Yeah.
Oh,
Yeah, this is the cowboy, what's left of it.
Oh,
All right.
gotcha.
Oh, you didn't notice that, huh?
No,
Okay, yeah.
I thought it was something else built the
We
bone.
call him Shorty. No,
Yeah.
sorry.
Nehemiah, huh?
Right, and this looks even like preserved flesh, okay, which is very interesting. Now, we see this some places in a soft form, like the bogmen in England, okay, these tannic acid swamps. You drop somebody in there, okay, and they don't rot because they're anoxic environments. And so when you pull them out, you get people several thousand years old, and you see all skin folds and all that, okay? There's the guy on the top of the Alps, same sort of thing. He was frozen up there and kind of semi-mummified, and you can find that. In South America, you can find people buried at the tops of mountains. They used to do human sacrifice, particularly with children. And these are mummified too because of the conditions. You want to add to that?
A little bit. You'll notice in this area that some of the plumbing gets lined up, quicker than you like. You end up changing fixtures. Okay, I was down at Riverside Falls, which is a tributary
Travertine.
to the Colorado River. It's a canyon west of the Big Grand Canyon. And in Riverside Falls, you have the water there, a very beautiful kind of blue, or a green blue. And the water is rich in a chemical salt that leaves a lime deposit, and those deposits are left very quickly. So if you look at where the water isn't moving quite as fast, you see kind of a cluster of grapes, kind of bubbly formation, although it's solid, and it's a brown limestone, and that rock is actually accumulating very quickly. So what you have is naturally occurring, whether in a river like you see there, or in a water flow where there are limestone caves. You have water that is highly soluble form, a soluble salt, if you will, that settles out and hardens like concrete. It fuses to itself real well. It's a fairly hard rock, and this is a process that happens actually quite quickly. Well, if anything is immersed in a solution with this, then you have, just like you see in the plumbing, the limestone accumulating wherever it can. And if it is porous, it's not too hard to imagine that the limestone is accumulating in between the fibers, and then the pores of leather or whatever else is in there.
The bone or whatever is replaced by minerals, cell by cell. Now again, that's, well, one of the reasons you have a water softener if you live where hard water is because it has that capability in there, and you don't like that, okay?
Yeah, so this formation is very quick, and it is a very reactive kind of thing. You have chemicals here that do what they're going to do quickly and once. You know, once the deposit is made, you have the chemical now in a non-reactive solid form. And so we don't see the situation as often now because we don't have hundreds of square miles of freshly dissolved volcanic ash.
Thank goodness.
And right,
Yes.
okay, yeah, the volcanic ash is a source of reactive soluble
Silicon.
salts that are looking for opportunities to react with something, or to occupy something, or to solidify somewhere. And these are very active chemical processes in that you have, in short time, a fast transition from something in solution to a non-soluble solid. And it's non-soluble, it will not dissolve.
Right, and the nature of the solution and the temperature, some other things might be involved in that. So think about something the size of the flood. You're scraping off things, dropping it in certain areas. You've got a huge bunch of heat because we think at the time of the flood the continents separated quickly. So you're developing a lot of heat in the oceans. You've got the perfect mixture to do a lot of cool stuff, all right? From a geologic perspective. Go ahead.
There's a difference between the fossils after the flood than those before, because the ones after are more limestone, more bogs, more permafrost, while the flood fossils are mostly silicon produced by volcanic ash, and there's a big difference between them.
And right now, creationists think that probably the end of the flood was somewhere around the end of the Cretaceous. Okay, what is that, CT? I can't remember. Cretaceous. All right.
I came to that conclusion a while back.
Yeah. The layers afterwards would probably be post-flood local catastrophes. The layering is different. The layering is more local in extent. So there's lots of differences there. This is where you see most of the mammal fossils. Okay?
No dinosaurs.
Because that would have a spread of mammals post-flood, we think. Before you got the dinosaurs in Cretaceous, Jurassic, Triassic, along with other sorts of things in there. They also have a large amount of biomass, okay, which we'll talk about when we get, if we ever get there. Go ahead.
Yeah, the modern equivalent of rapid fossilization you see all over the place is concrete. Now with concrete you have some kind of a material that's good for structure, the gravel and the sand, and then you have this gray powder which is formed in something remarkably like a volcano, a staggering amount of heat to create something in a chemically unstable form that then jumps into action when it again meets water. It had had the water dried out of it, and it is brought to a high energy state chemically. And so if you walk down the sidewalk on a summer day, you see little sparkles in the sidewalk. Okay, that is crystal formation that was happening very quickly as the concrete formed. And then you go to places like Canyon de Chelly or any place where the sandstone is quite hard, You walk over the surface in certain light conditions, like most of the day, look down and the whole ground is sparkling, okay? A very similar kind of process. You have then, what wasn't the cement plant, but rather the volcanoes, burping a whole lot of what amounts to concrete cement. It gets in contact with water, a reaction takes place, and you have something that is very strongly fused with crystalline structure, and that resulting structure is not water soluble.
That's essentially what dinosaur tracks are.
Again, you
It's
see,
kind of a cement,
right.
while the bones tend to be more in the ash.
Well, the bones
Which are often
calcified,
above
so
the tracks.
They're getting calcified. Now, what we see in the bones also is soft tissue, and that's something that's come
Which
out,
is preserved inside the silicon.
really weird.
It's sealed in.
So you got that. Oh,
Time for the drawing.
time for the drawing. Okay.
Okay, we're drawing for the book. And so here it is. And we're going to let you do the random act of kindness.
Okay. 100 or more miles in the canyon. These sorts of things. This is big laying down. We don't see anything like this today. All right. This speaks of a lot bigger event. Okay. For instance, the sandstones. Okay, one layer covers all this. That's big. Okay. That's not a little sandbox. That's not even a little lake. That's a big lake. Okay. These are the kind of thing we see. That's the kind of stuff we would suggest we would expect from a flood. Coal seams. Go back to Pennsylvania, and then in the Midwest here, you've got giant coal seams. All right. Now, these are thought to be swamps or bogs. Well, that's a one big bog. Okay. And it looks. There are several other features we could point out that we would suggest. Looks like it was coalified quickly. We find tree bark in there, similar to what we saw at Mount St. Helens. The nature of it is very interesting when we look at these.
What constitutes a swamp?
Well, again, during the flood, you're going to have a lot of vegetation that's sheared off and perhaps dumped in an area.
The
Okay?
vegetation makes
Right, because
that.
coal that's basically what it is, organic material.
Okay.
Some of it gets cooked in the right kind of way, you get coal. Some of it gets cooked more, you get oil. So, when you put stuff in your tank, you're essentially putting the remains of what was there. We would suggest before the flood, the evolutionists would say, from times past. Okay? Yes, sir.
Oil is usually in our salt domes. Why is that?
Well, if we knew all the stuff we wanted to know about oil, we would find more even, okay? It just seems to be, I'm not sure why it's under salt domes as much, but the nature, it has to be cooked and some other sorts of things in nature, okay? And so you find it typically in certain things or in between certain layers. Now, we're doing a lot more. We keep finding more stuff. The environmentalists say, we're at the end of oil, we've reached peak oil, we're going down, and then we have another big strike, okay? Like in North and South Dakota right now. Fracking is allowing us to do a little bit more too, as far as that goes. So we're finding big deposits still, okay? Yes, sir.
Also, some of the oil drillings that they've done, they've tapped them out, they're finding that they're refilling.
Which is interesting.
There's something below those oil pockets that's creating more oil.
Fascinating, isn't it? Now, there's Russians that say actually this oil is actually being manufactured now. It's similar to what he's saying, but it's still a little different.
No, this is natural. It's percolating up from deeper levels and percolating back up into those areas.
Now, what does that tell us?
Almost
That's
like a
why
water
you
tap.
find it in the salt dome, because it's working its way up.
Working its way up, all right. It also perhaps tells us, and I always like to keep this in mind when we're talking about science, we don't know everything, all right? We know, yeah, I know. Some of us, what was it, Erasmus, at the time of Martin Luther, was supposedly the last man who was, what do they call it, knew all the knowledge of the earth at that time, or something like that. Nobody does. God does, okay? We don't.
He was amazing.
And so when people say, oh, you can't do this, all right, we can go back in history and look at all those people who said we will never be able to fly. It's just not something we will be able to do. Somebody can tell the right colors.
What's the difference between producing coal and producing petroleum, like oil?
It has to do with the how it's cooked, I believe, and how it's buried, okay? Yes.
We had some oil, we had some produced in our backyard.
What,
No.
oil?
Well, no, what she's
It
talking
smelled-
about,
it
what she's
smelled like
talking about
oil.
is we had a pool dug, and about 3 feet down from
5
the top,
feet.
5 feet down from the surface, there was a seam that was dark, it was black, about 1 inch thick,
Interesting.
all the way around, you know, all the way around. And you dig your fingernail in there and smell it, it smelled like petroleum. So I went back to, because we bought the house new, we had the plot plans, and when we first moved there and saw the house, there were weeds that were just 3, 4, 5 feet high through the whole backyard. We found out that that lot, when it was leveled, was backfilled to 5 feet. So I'm thinking it had buried organic, vegetable, you know, not vegetable, but organic matter, the vegetation, compressed it over a period of only 4 or 5 years and produced that seam.
Interesting. I don't know enough about that sort of thing to, I do know that there are some people in their backyard, they have these little things that are going up and down in there. and getting oil.
We didn't get that much.
Not that much, all right?
They didn't let us do
Sorry
it
about
anyway.
that, yeah. All right. Deformation of sediments before hardening. Now again, you think a layer's laying down, this stuff's hard, right? Okay. Old Earth scenario, these sediments brittle when deformed. A young Earth scenario would say these sediments are soft when deformed. So let's look at some of these sediments. We're looking at stuff here in the Grand Canyon. This is a cutaway view. You can't do this, but you can see some of these in the Grand Canyon. So we're looking at volcanic layers that go over the side. We're looking at some of what we might think are creation weak rocks. They're perfect for having fossils and they don't have any in them. And then the major layers of the Grand Canyon. Okay, we'll come, all right. This is our view of perhaps what's going on here. These rocks were tilted at the time of the flood, that kind of thing. This is all developed in a book called Grand Canyon Monument to Catastrophe, if you want to read more on that. All right. Let's see, where's my picture? Okay, we got upwarps and all this. This one probably gives you an idea. What we would call soft sediment deformation. These are people. These are the layers.
So how did that happen over millions of years? How did that get deposited if you're an older?
Well, it's deposited. The question is it soft when they're all bent? Okay? Just to look at it,
Yeah.
we might be able to make a case that these things were all still soft when they were bent.
Right.
However, if this layer is a lot older here than this layer up here, the case would have to be made that this must have hardened. I mean, if you're sticking out of the ground, you know, or you're laying there for millions of years, you dewater, you do all kinds of stuff. I mean, you know, the chemical processes are working, as he was talking about here. And so you're going to solidify these layers. All right? Now, they would say perhaps slowly over time you can bend these if you're, you know, just pressures. And you see that, well,
With
do you see
volcanic.
that? I've got a tree right now that's starting to pull the sidewalk. Is the sidewalk slowly bending? Well, maybe if I had stuff on top of it, it might. Usually what you see is crack, right?
Yeah.
All right.
So the
Faults.
key component here is that these layers are not broken as hard rocks would break.
It would seem so, right. You have soft sediment deformation.
It's all a uniform, unbroken, putty movement.
If they were solidified, you might expect more of that, okay? Now again, you don't have to be a geologist for some of this stuff. You can look at it yourself and go, that's interesting, okay? Now you want to study more, find out what, maybe an evolutionist has a good explanation for all these. I mean, there's some places right out here in Anza Borrego where it just sort of looks like a washing machine is turned on. It's really interesting. I've got a picture of my car parked near one of those, all right? So it does look like it was soft when it was bent. Interesting. Rapid canyon erosion. Here in the Grand Canyon, we see some of that. Okay? Because there's not a lot of talus in some of these slopes, it looks like whatever came through here cut it rapidly. And make the case for that when we look at some of the rapid canyons carved around Mount St. Helens. Okay? It looks like there are hard and soft pieces in here, and you can tell the water went through there. And we've suggested there was a dam, a lake above Grand Canyon, and a natural dam that broke free and came ripping through here because all the soil went down in the Gulf of California, or a lot of the sediment either spread out there or went down in the Gulf of California. So for instance, there's an old Flintstone cartoon where, you know, they're looking at this little stream in front of them and they're saying, you know, they say this is gonna be a big thing someday, you know, it's the Grand Canyon, because, you know, it takes a long time to cut it. Well, it does, if you do it that way, all right? But if you put a lot more water in there, you can do it quicker, all right? Again, just saying, you do the same sorts of things. Now, is there evidence either way on that?
Can I say something?
Go ahead.
The Baus Formation came from the canyon, and the museum over here, Dr. Reynolds, took us out there. And the mystery is that material is all Pleistocene. It only has mammoths and things, which are all post-flood, no dinosaurs or nothing. And that's the material that came out of the canyon.
Right. So
They don't know what happened to the rest of it, though.
yeah, it's gone. Okay. All right. So we see stuff like that. Now,
what's that theory? Is that the Great Basin theory? Is that the Great?
well, catastrophic geologists like Dr. Austin, who used to work at ICR, are hypothesizing this. See, the Grand Canyon is in an upward, which is really weird. If you look at, say we're looking at Arizona, here's the southern part, here's the northern part, you're looking at it like this. It goes like this, all right? And the Grand Canyon is sort of opened up right like that, okay? So some would say, well, the river slowly cut it, you know, over time, that kind of thing. But it would almost suggest that it has to go uphill. A better explanation is a catastrophic one, we think, that took it out through there quickly. Okay, and there's several reasons that he mentions in the book for that.
Which is something up in Colorado, right?
It's in Arizona.
If
Oh, yeah.
if you take a spotting scope or some really good optical instrument, or I took a great big bird lens to the Grand Canyon and looked for talus down at the bottom of the canyon, and it's hard to find. And another thing you see is in some of the upper slopes, you see you know, rocks as big as a house on a very steep slope that have slidaways, and you can see the scratch where it slid, and it hit something and stopped. And so you see a lot of frozen motion if you care to look for it.
Well, there's actually boulder layers in some of the canyon also. Certain layers, particularly down here, where you have, you know, house-sized boulders, okay? And it looks like they've rolled a little bit. Well, you know, you can calculate how much you would need to move one of those babies, all right?
But the amount of talus down at the canyon is remarkably little.
That's the junk that falls off the side. all
Yeah,
right?
and there's just a few of those.
Right.
So you
You
have
expect a lot more, perhaps.
You have a combination of the canyon actually looking very freshly cut. And if you look at the features, you notice they're not rounded out, they're remarkably crisp. And in some places where you have steep slopes, you see where rocks have slid a little bit and somehow stop, which might be the thing you get if you have receding water. A little bit of slide and it stops. And then the bottom of the canyon is overall remarkably clean, just a little bit down there, but surprisingly not much.
Well, the river carries away a lot of stuff. There's lots of junk going through the Colorado in the canyon. But again, like you mentioned, you would expect more talus here perhaps, because it's a desert environment for the most part. When you get up on top, you have more, you have evergreens and all that, but it's a drier climate. And you'd expect, there's several things you'd expect if it was very, very old, perhaps. All right, now there are various explanations. Again, we're talking about the constant rate. Well, yeah, every once in a while something comes through there and washes it out. Well, fine, okay. All right. Okay, dating. All right. Let's see, do we have, I'm gonna mention this a little bit. All right, we find different interesting things when we look at the canyon. Isochrons are a method of dating, okay? And what ICR did in some of these things is we looked at isochrons. There are various decay series or chains, okay? Rubidium to strontium, lead to lead decay chains, potassium to argon, these sorts of things. Each one of these are radioactive minerals that we can use for dating. We can count what's in there, so to speak, and we get an age for things. So we did some dating, for instance, of the basaltic rock here on the Uncreek Plateau. Okay, I'm not sure if this was part of the RATE project or if this was in the literature itself, but it was interesting. Isochrons are supposed to be some of the more solid ways of dating things. I won't get into all of it, just to give you an overview. Well, anyway, when you date it by different methods, what's really interesting is the methods don't agree with themselves. So this gives the age of this particular lava flow, which we know is probably pretty young because it's coming from the top and going over the side, right? Okay, so relatively, it's got to be young, younger than this stuff. But it gives a lead age of 2.6 million, 2,600 million, 2.6 billion years old. All right. But when we did it by rubidium strontium isochron, we get 1,300,000,000 years old. Now, that's quite a difference, just in those two. When we did it by the model ages, and that's a different tweak on the dating methods, all right, maybe 1.2 billion years old. And then when we did it by potassium argon method, which is a gas that gets out of there, and we look at various things, it comes up very young. All right? So they don't all agree with each other. What you do is you choose the best one. So my guess is if you were an evolutionary geologist, you would say, well, obviously this one has got the best dating methods because something's going on with these other things, and there are various things you can talk about as far as raid or initial conditions or something like that.
Don't all of those have an assumption based on the layer of, you know what I mean? There's nothing.
When you date the layers like this with these methodologies, yeah, well, like you said, the assumptions are these: your starting rate, your constant, you know, what you have there. Okay. Some layers or some methods are better for dating than others for various reasons. There could be that contamination gets in there of some sort, okay? And certain rocks might be better than other rocks for that kind of thing. Certain parts of the rocks, okay? And we did the same thing here at the Cardenas lava flow. And when you do it in various different types of models, it's not as much, but you do get a lot of play in there. Anywhere from over 1 billion years old to 800 million. So, you know, a couple 100 million among friends. Not too bad, all right? What's interesting, though, is some of these, look at that, this one comes up older. Why is that? Well, it turns out whatever was in this lava mix, and what's assumed is it starts out at age 0 when it blops out of the face of the earth, that assumption might not be correct. In other words, the initial conditions might be off. It might have an appearance of age, all right? That's fine. Again, what I'm trying to tell you, too, is dating methods are really hard, okay? You've got all kinds of assumptions going into these, all right? And if you don't think so, go pick up a book on radioisotope dating. Try and read through it a little bit, okay, and see what they go through. There's a lot of machinations here, and it's fun, actually, conceptually, okay? I'm not sure how much it is. Now, I remember when we were doing the RACE project at ICR, where we did some dating. And I remember the hammer in the geology lab next to mine. Boom, 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 all the time. He's crushing up these minerals. He's putting them in heavy types of liquids because you have to purify the stuff and all that. Took a lot of work. Bill Hosch was one of the guys who did a lot of that. He's spoken here before, I believe, right? Mm-hmm. Okay, yeah. So he did a lot of that for preparation of the specimens. Okay? Again, just to show you, this layer should be a lot younger or older than this layer. And yet, okay. Now we might explain it by different things. In other words, this one, for whatever reason, came up with some contaminants or something like that. It just looked older when it first came out. Okay, fine. How do you know some of these others didn't do some of that, though? All right? The initial assumptions here, the starting conditions are very important. And unless you were there, perhaps, watching it form, you might not. You know, that's very interesting. Now, scientists are trying to take into account all that. And you can read the papers. It's very complex, and these are very smart people. So I'm not saying anything that way. I'm just saying the methodologies are very, very hard to do, and there are assumptions built into it that you may or not be assuming correctly. Okay? Okay. Because we got to move on here.
Inaccurate.
Hit some of these. Okay. What we did in the Grand Canyon and in other places, okay, In several layers of the Grand Canyon, there's coal seams or places where you can date things, tree branches, this kind of stuff. You can use C14. Now, carbon-14 is a radioactive form of carbon. Where's my pen? Okay.
50,000.
Usually what you have in the atmosphere is carbon-12. But every once in a while, maybe 1 in a trillion or so, you have a C14 or atom. These are radioactive. Well, you all take in carbon, okay? And so you're all slightly radioactive, okay? Okay? When you die, you stop taking in carbon. Makes sense, right? You're dead. And so, if our method is correct, and what happens is C14 has a half-life. I got pictures of the half-lives in here, but we're running out of time. What that means is radioactive decays at a certain place. So if you had